Check this out. By turning this knob, I can control the LED brightness in real time. Turn it left, the LED dims. Turn it right, it gets brighter. This is analog input in action, and today you're going to learn how to build this exact project.
Now let's talk about why this is different from what we've done before. In Project 3, we used a button, which gives us digital input, just two states, pressed or not pressed. A digital signal is like an on-off switch, only high or low. But a potentiometer provides analog input, delivering a whole range of values instead of just two. The Arduino can read 1024 distinct voltage levels on its analog pins, from 0 to 1023 in code. This lets us create smooth, gradual control rather than a simple on-off. Think of a light switch. It's digital, either on or off. A dimmer switch is analog, letting you choose any brightness level you desire. Today we'll build that dimmer switch with a potentiometer and Arduino. By the end, you'll see how analog input lets you make your projects more flexible and responsive.
First, let's understand what a potentiometer actually is.
A polished potentiometer with 3 visible pins rests on a clean surface. The camera circles the potentiometer, revealing the knob from a smooth side view. A tight zoom focuses on the 3 pins, each clearly distinguished. The view transitions to an internal diagram, exposing the resistive track and moving wiper. The knob turns steadily, moving the wiper along the resistive path. A digital meter pops up, its reading smoothly climbing from 0V to 5V as the knob rotates. Simultaneously, a glowing vertical bar rises, visualizing the increasing voltage divider output. The bar fluctuates gently as the knob continues its smooth rotation, illustrating real-time voltage change. A brief label appears, confirming the component is a 10K coil potentiometer. Finally, the camera pulls back for a full view, showcasing the rotating knob, meter, glowing bar, and highlighted value in harmony.
Here's what you'll need for this project. You'll need your Arduino Uno and USB cable, of course. Then you need one LED, any color works. A 220 ohm resistor for the LED, that's the same resistor we've been using. A 10 kilo ohm potentiometer, this is your analog input device. A breadboard and some jumper wires. Before we start wiring, let's look at the Arduino's analog input pins. They're labeled A0 through A5, that's 6 analog pins total. Alright, let's build this circuit step by step. Always, the long leg is positive, that's the anode. The short leg is negative, the cathode. First, take your LED and place it on the breadboard. Put it across the center gap of the breadboard so the 2 legs are in different rows. Next, take your 220 ohm resistor, that's red, brown color bands. Insert one end into the same row as the LED's long leg. The other end of the resistor goes into a different row. Resistors don't have polarity, so either direction works fine. Now take a jumper wire and connect Arduino pin 9 to the free end of the resistor. We're using pin 9 because it's a PWM pin, which we need for controlling LED brightness. You learned about PWM in Project 4, so this should be familiar. Finally, for the LED circuit, connect the LED short leg, the cathode, to the ground on your Arduino. Perfect! Your LED circuit is complete. Now for the potentiometer, this is the new part. Hold your potentiometer so the shaft, that's the part you turn, is pointing up and the 3 pins are pointing down toward you. The 3 pins are typically in a row. The left pin will go to 5 volts, the middle pin, that's the wiper, will go to analog input A0, and the right pin will go to ground. Actually, you can swap left and right if you want, it just reverses the direction of rotation. Push the potentiometer into your breadboard. Make sure the 3 pins are in 3 different rows so they don't short together. Take a red wire, using color coding helps a lot, and connect the left pin of the potentiometer to the 5-volt pin on your Arduino. This provides the high end of our voltage range. Now take another wire, maybe yellow or green, and connect the middle pin of the potentiometer to A0 on your Arduino. A0 is right next to the other analog pins, usually near the power pins. This is where the Arduino will read the voltage. Finally, take a wire and connect the right pin of the potentiometer to the ground pin of Arduino. Now let's write the code that brings this project to life. The code for this project introduces a few new concepts, but don't worry, I'll explain every single line so you understand exactly what's happening. As always, you can download this code from the link in the description. Let's start at the top. We define two constants, constant pot pin equals is 0, and constant LED pin equals 9. These tell the Arduino which pins we're using. A 0 is our potentiometer input, and 9 is our LED output. In the setup function, we do two things. First, pin mode LED pin output, this sets pin 9 as an output, just like in previous projects. We don't need to set pin mode for analog input pins because they're inputs by default. The second line is new, serial.begin 9600. This initializes serial communication between the Arduino and your computer. The number 9600 is the baud rate, basically the speed of communication. Now the loop function, where all the action happens. First line, int pot value equals analogRead pot pin. This is the new function we're learning today. AnalogRead reads the voltage on an analog pin and returns a number from 0 to 1023. This is where the map function comes in. Look at this line, int brightness equals map pot value, 0, 1023, 0, 255. The map function takes a number from one range and converts it proportionally to another range. Next line, analogRead LED pin, brightness. You learned about analogRead in Project 4 when we did LED fading. This sets the PWM duty cycle on pin 9, which controls the LED brightness. 0 is off, 255 is full brightness, and anything in between gives us a dimmed LED. Now the serial monitor lines. We have 4 lines here. Serial.print pot value : prints the text without a new line. Then serial.print pot value prints the actual number. Then we print some more text, and finally serial.print brightness prints the brightness value with a new line at the end. This creates output like pot value : 512 arrow brightness : 127. The serial monitor displays this in real time so you can see exactly what values your code is seeing. Go to Tools, Board, select Arduino Uno. Then Tools, Port, and choose the port where your Arduino is connected. If you're not sure which one, unplug your Arduino, look at the list, plug it back in, and see which new port appears. Click the Upload button, the right arrow at the top. Your code compiles and uploads. Wait for the Done Uploading message. You'll see the Arduino's RX and TX lights flashing during the upload. Once uploaded, immediately go to Tools and select Serial Monitor, or just press Ctrl-Shift-M. A new window opens. This is the serial monitor. Make sure the baud rate at the bottom right is set to 9600 to match our code. Now for the fun part, let's test the actual control. Watch what happens when I turn the potentiometer. Turn it to the left, and the LED gets dimmer and dimmer until it's completely off. Turn it to the right, and it gradually gets brighter until it's at full power.